Hi, in this video, I'll show you how to do simple linear least squares regression in Microsoft Excel. I'm using version 2016, but earlier versions are similar, and I hope that later versions will be similar as well, just maybe buttons in slightly different places. There's two main techniques to do this. I'll show you both of them. The first one involves starting off by creating a scatter plot. But before you do anything, we have to prepare the data set. So on the screen is a data set from a survey I did in my statistics class several years ago. And when I mean prepare the data set is, as you can see here, this one student decided not to include her height. So in order for Excel to understand what's going on, I'd either need to approximate the height and enter in a value, make up a value, if I remember what the student looked like, or maybe I could just delete the row entirely. Now, every other observation here is purely numbers in the first two columns. And so that's good. That's all I need to do. The first technique we're going to use is to create a scatter plot and then fit a straight line through that data set. However, before we can create a scatter plot, in addition to preparing the data, by deleting non-responses and making sure that they're just numbers in those first two columns, you also have to have your first column be the x variable, your independent variable, and the second column will be your y variable, what goes on the y-axis, your dependent or response variable. Alright, so after we do that, and I did prepare my data set to look like that, just highlight the first two columns and click on Insert. Next, you're going to go over to what looks like a scatter plot, x and y axis with a bunch of dots, and you want it to be unconnected. So like that. And there you go. Here's a scatter plot of the data. It automatically titles the scatter plot with whatever you labeled your y-axis to be. But you can change it if you like. So scatter plot or scatter graph, whatever you want to call it, of shoe sizes. And you can even label your axes as well, which is always a good idea, by clicking on Design. There are some quick layout options that include X and Y axes. Over here is a good one. I don't like since we only have one kind of dot, there's no point in having a key, so I will delete that key. And let's see, on my x-axis is height, measured in inches, and my y-axis is shoe size, and I asked my students to give me the US adult male version of their shoe size. Okay, so now we got a pretty good picture of what the data set looks like. Next, you're going to click on one of the dots and all the dots will highlight. Then right-click and click on Add Trendline. Automatically, this options menu will pop up. And there are other options. You could fit an exponential model or a logarithmic model or other kind of models, polynomial, through the data. But in my class, in my statistics class, all we cover is linear regression, so we'll just fit a straight line through the data. Next, we want to know what the equation of that line is, and we can change the colors of it and a bunch of other options as well in the other formatting options here. But all I want to do is I want to find out what the equation of that line is, and I'll also want the r-squared value, because that'll be useful for interpretations and to tell us how useful the model is. And there you go. So our model is that our predicted values of y, this should be y hat equals, but Excel just writes y equals approximately 0.5x minus 24.4, and r squared is about 73.5%. All right, this is all my students are required to do. However, you could get a little bit more of a more formal way of finding the regression printouts, which will give you the standard deviation, p-values, a bunch of other good, useful information for future coursework. So the way you do that is you need something called the Analysis Toolpak. So to do that, click on, well, first off, you might already have the Analysis Toolpak installed. If it is, you click on Data, and on the upper right corner, there should be an option called Data Analysis or Analysis. I don't remember exactly what it says, but it's not there. So let's click on File, go to Options, and one of the options is for add-ins. So click on Add-ins. On the bottom, it says Excel Add-ins. Click on Go. And if you notice, the Analysis Toolpak is not checked off, so just check off the Analysis Toolpak options and click on OK. Now, it doesn't look like anything happened, but now if we click on Data, there is a Data Analysis option. So let's click on that. In this Data Analysis dialog box, there's a whole bunch of different types of techniques that you can use. It includes all these different wonderful statistical functions. The one we want is regression. So let's click on regression, and this will do multiple regression as well. But again, we're just talking about simple linear regression for now. So first you want to select your Y values, and I'm going to include the label. So I'm going to include that title of shoe size for my Y values. Again, Y was in our second column. So I'm just going to highlight all the Y values. And sometimes an error occurs if you select the whole column. So just left click on the first cell and then hold down the button. I'll do it one more time. Okay, so for the X values, my title here is an A1. I just want to drag my mouse all the way down to the very last item, the very last cell, in this case A58, and then let go of the left mouse button, and then hit this button to go back. Okay, I need to tell that I am including labels, and that's all I need to do. There are some other options. You can include some line flip plots. That's the regression printout, that the scatterplot printout that you saw. These other options are really useful for checking regression assumptions, as well as the normal probability plot that will check for normality. But for the purposes of this class, just an introduction to regression analysis, all we really want to do is look at this printout. So when you're done, just click OK. And this is a fairly standard summary output, often called an ANOVA table or ANOVA analysis for regression. The formatting is always a little bit weird. I like to expand the first column this way you can actually see what's being written. And you can actually highlight these cells and bring them over to Word and copy them into anything you want to look at. So I can just press Control-C for copy, Control-V for paste. And again, the formatting comes out a little bit weird, but it's all here. This is what you need. The y-intercept is this negative 24.4 that we saw before. The slope is the next number. It's the number next to height. It's the 0.4899 that we saw before. So if you wanted to build a model, it would be that y-hat, which actually write that by using the equation editor. We want to have our symbols, our hat symbol. So it should be y-hat equals negative 24.4 approximately plus 0.5x. So that's my model. And again, I just took these coefficients to fill it in. Other things to point out, let me go back to the original printout. This R square is the same R square value that we found using the scatterplot technique. Adjusted R squared is usually about the same number, especially for simple linear regression, but this will be more of an issue when we deal with multiple variables and multiple regression. This multiple R value, this is the Pearson correlation coefficient sometimes. So this is that lowercase r is the way I usually write it, the Pearson correlation coefficient. However, Excel always makes this number positive, even if there's a negative relationship. So this will be R. So R in our case is going to be 0.8577 approximately. as long as the slope is positive, which it is in our case. If the slope was negative, then we'd have to know that r really should be a negative number here, and Excel won't tell us that. We'd have to do that manually. If you don't want to use this technique, if you want to use the scatter plot technique, let's go back to that. Sheet 1. So here's our scatter plot. If you just want to use the scatter plot technique and you don't want to do that whole printout of all those different numbers, you can actually calculate the Pearson correlation from the r-squared value. You just take the square root. So let me open up Windows Calculator for a moment. Okay, so I just want to do the square root of 0.7356, square root that, and I get that 0.8577 that we found our correlation coefficient R to be. And again, you'd have to know whether or not you should make it positive or negative based on whether or not the slope is positive or negative. Since clearly our slope is positive, this R value should be positive. But if our slope is negative, then R would be negative. And that concludes this video.